Hello, hello, hello. This is Nicholas, and I'm doing kind of an extension on my epsilon delta proof video, and I'm going to be doing it for a quadratic function this time, so things are going to get a little more complicated. So now what I'm going to start with is I'm going to start with this limit, and we're going to prove this limit. We're going to prove that the limit as x approaches 5 of 3x squared minus 1 would be 74. And you say, well, I can just plug in 5 into x squared, get 3 times 25, 75, minus 1, 74. No, we're going to do better than that. So we're going to start with our limit definition, which I guess since I still have it on the page from the last video, I will bring it down here. So we're going to copy that. And just for reference here and pedagogicalness, however you say it, I'm going to put it there. And let's just scroll down to here. So this is what we're doing. Okay, so we have that the absolute value by the, this part here will be working backwards. To see in the last video with the linear limit proof, we had to find a value of delta in terms of epsilon, and that's what we're going to have to do here. So in my backwards work here, that's what I'm going to try to find, and then later on I will do the formal proof. So I'm going to start here, and I'm going to work backwards to this definition here. So from this part here, I have that the absolute value of our f of x, which is 3x squared minus 1, minus our L, our answer to the limit, which is 74, is less than our delta. And so in other words, the absolute value of 3x squared minus 75 is less than delta. Or epsilon, not delta, my bad. So what we want is we want to turn this 3x squared minus 75 into an x minus 5. So how can we do that? We need to do some more work, basically. With the nonlinear functions, it's usually easier to work towards solving for x itself, and then we will introduce some value of a of our, in this case, a is 5. So we're gonna begin with simplifying inside this absolute value right here. So we would get then, by the definition of absolute value, we would get that negative epsilon is somewhere in between, or 3x squared is somewhere, 3x squared minus 75, somewhere in between negative epsilon and epsilon. Okay, so now I want to solve for x, so I'm going to add 75 to all sides of this inequality. So I get 75 minus epsilon is less than 3x squared is less than 75 plus epsilon. Okay, and then likewise, 25 dividing everything by 3, 25 minus epsilon over 3 is less than x squared is less than 25 plus epsilon over 3. Okay, and then taking the square root, and we're assuming that x is going to be positive. So in other words, when we take the square root of x squared, we're just going to get x, not plus or minus x. So now we have the square root of 25 minus epsilon over 3 is less than x, is less than the square root of 25 plus epsilon over 3. Okay, and now I want to take this x here, right? My whole goal was to solve for x and then introduce my value of c, or of a later, of this 5 here. So now what I need to do basically is I need to subtract 5 from all sides of this inequality so that I can have my x minus a in this limit definition, or in other words, my x minus 5. So what this tells me now is that if I subtract negative 5, or if I subtract 5, that if I subtracted negative 5, that would be the same thing as adding 5. I subtract 5, I get negative 5 plus square root 25 minus epsilon over 3, that's a pretty bad epsilon, is less than x minus 5 is less than negative 5 plus square root 25 plus epsilon over 3. Okay, so we can't just put this back into the form, into this form here, and just say that the absolute value of x minus 5 is less than the absolute value of this, and then we could just let that be delta, because these two things are not the same, right? Because we have this minus here and we have this plus here. So we need to do something different here. So what we can do is we say that we're going to expand this absolute value expression instead. And so basically the idea is that there are two different candidates that we can pick for delta, and we're going to need delta to be less than or equal to both of them. Right? From delta is going to need to be less than or equal to both of them from right here. So basically what we're going to say is that we're going to let delta be the minimum of these two possible candidates, the two possible candidates being this and this. So now what we can say is that the left end expression right here, the left end expression was the same thing as negative delta. And so what we can say basically is that delta is going to be equal to the minimum value of 5 minus square root 25 minus epsilon over 3, comma, negative 5 plus negative 5 plus square root 25 plus epsilon over 3. So it's going to be the minimum value of those two things, because we need both of those two candidates for delta to be less than or equal. We need these to be the lowest that they can be. That's the whole idea of this limit definition. So now we're actually ready for the proof here. We are going to say let epsilon greater than 0 be given. So we have some epsilon greater than 0. And so again, this indicates that our argument will work for every epsilon. Now we need to introduce another epsilon here. We'll call it epsilon sub 2. And so the reason why is because we need epsilon itself to be less than 75. Because if epsilon is greater than 75, 75 over 3 is 25. And then if we in other words, this can't be negative. This 25 minus epsilon over 3 can't be negative, because you can't take the square root of a negative number under the reals. So we need to introduce a slightly smaller epsilon where it's needed. So what I'm going to say is that I'm going to let epsilon sub 2, a different epsilon, be the min of, so the minimum value of these two of epsilon, I wrote E, not of epsilon, and I'm just going to pick some number smaller than 75, so, I don't know, 72. Okay. 72. So, and I'm just doing that so that we're not taking square roots of negative numbers here. So, if we have, since epsilon sub 2 is greater than 0, right, then we're also going to have delta being greater than 0. because that was the whole point of picking that epsilon sub 2 was so that delta would be greater than 0 and that we wouldn't have an undefined delta, right, when we have a square root of a negative number. Okay, now using the limit definition, we have that the absolute value of x minus a is less than delta, and it's greater than 0. So what that means is we can expand this out, and we can say that negative delta is less than x minus a is less than positive delta. And so our negative delta is negative 5 plus square root 25 minus epsilon sub 2 over 3, which is less than the absolute value of x minus 5, which is less than negative 5 plus square root of 25 plus epsilon sub 2 over 3. So we have these two candidates for delta, and we need to expand the absolute value inequality so that we can use both of them. So now, and I put the epsilon sub 2 in there because we don't want square roots of negative numbers. And then also negative delta will be our, right, notice that these and these are negatives of one another. In other words, if I were to take this and multiply it by negative 1, I'd get that. So these are negatives of one another, and so that's allowed right there. So now what I can do is I can add 5 to both sides because I don't want those 5s in there. That kind of crams it some more. So just do that. Always try to... Maybe this was more work. Okay, so I just added 5 to both sides. Okay, now we have that. And so now what I can do is I can square both sides because I don't like these square roots that much. So we have 25 minus epsilon sub 2 over 3 is less than x squared is less than 25 plus epsilon sub 2 over 3. And so then I can multiply this whole thing by 3 because ultimately what I want to get to is my 3x squared minus 75, right? Then I'm going to subtract 75. So now I need to multiply this whole thing by 3. So I get 75 minus epsilon sub 2 is less than 3x squared is less than 75 plus epsilon sub 2. And then I can subtract 75 from both sides, and I will get negative epsilon sub 2 is less than 3x squared minus 70, let me just read, less than 75 is less than epsilon sub 2. Okay, so, and this epsilon sub 2, I just picked 72. It doesn't really matter. All we know, though, that the epsilon sub 2, whatever value I pick, it's got to be less than or equal to our original epsilon. So now what we can say is that this 3x squared minus 75, well, first of all, notice that since these two are the negatives of one another, then I can write that the absolute value of 3x squared minus 75 is less than epsilon sub 2, but then I know that that is less than epsilon to begin with, and so again I can then split this up because I want my f of x minus my L. My f of x was 3x squared minus 1, my L was 74, so I can break this up into 3x squared minus 1 minus 74 is less than epsilon. And so since this choice of delta implies the definition for that the epsilon here that satisfies our limit definition, we can say with 100% confidence that the limit as x approaches 5 of 3x squared minus 1 is indeed 74. And so we can now say quo erat demonstratum. And if you've made it this far, if you're maybe trying to show off your mathematical knowledge, you can say, well, it stands